Okay, we're doing it now.
So?
Yep. This is looking good. Alright, I'll work my way around here.
Yeah.
Well, what is today?
Today
is the 2nd.
My birthday is November 18th.
This is a special day. It's election day.
Mm-hmm.
So who's going to win, the Democrats or Republicans?
Democrats.
Democrats. So it sounds like you guys are Democrats.
Conservative.
You're conservative. Well, you're a conservative Democrat?
Yes.
Really? What does that mean?
Like, help schools.
Okay, well, I think the liberals like to do that too. Anyway, now, you guys need to slide around more here closer to me. That's how we're going to be doing it. Because I don't have a tripod today. Now, I got a phone call from somebody who you might know. I'll have to read the name.
My teacher?
Nope.
My mom?
Your principal.
A principal?
Yes. She said she's your principal.
What's her name?
Olabumi.
No, I'm not a principal.
What's so funny?
What?
Come on back.
What's so funny? What?
Come on back here. If you're gonna laugh, laugh on camera. What's so funny about that?
Wait, what's Olabumi? Who's that?
Olabumi.
Who is that? Bakun.
Bakun.
I don't know.
You don't know who that is?
I don't know. Anyway, who's that?
I thought she said that your mom was her mom.
What? My mom's mom is Nigerian.
No. Your mom.
Yeah, my mom.
I thought she said that, like, Belangi is your mom, right?
Yes.
I thought she said Belangi is her mom.
What?
I thought she said that. Okay, she goes to PG.
Oh.
And she has trouble walking.
Trouble walking?
She can't drive. She has to have a Metro Access bring her.
Here?
To my place, because I'm going to be teaching her mathematics.
Oh, I think my mom was talking to you the other day. Yes, like last week.
So I thought she might be your sister.
No, it's not. I don't have a sister. We don't have a sister.
You don't have a sister. All right. All right, let's put that aside. Okay. Oh, so today is the date. Oh, it's the 2nd. We established that.
Yes.
Okay. All right. Let me find my pen. Tell me I don't have my... Oh, yeah, I got it. Right back here. Okay. Well, what were we doing last time? We were doing fractions, equations with fractions.
Yeah, we stay doing fractions.
Well, we're going to be doing that more, equations with fractions. Now, you had a problem for a while with just fractions in arithmetic. Now, but last time you seemed to know them pretty well. So what about today? Did you forget them by today? You know how to add fractions, and you know you need to find a common denominator when you add fractions. So that's not going to be a problem today, right? Okay. Let's look at equation. Well, let's just review real quick. Let's go back. Let's go down to 17. Okay. 17. All right. 17 is x over 3. It's not page 17. It's number 17.
It's on the front page.
It's on the front page.
What happened?
I don't know. What in the world is this?
That's the problem he gave me. I think it got smeared because he kept on taking the paper out.
All right, that's all smeared, so I won't have to write this over. I think 17 is the only one that didn't copy well. Plus 2x.
What? I wasn't there when you put out the front page.
Okay, I'm reading this, well, for the camera also, because the camera can't see the page. It's an equation. The equation is x over 3 plus 2x over 5 equals negative 11 over 5. Now, if you look at these first two terms on the left side, those are two fractions. Okay? You agree with that, I'm sure. And you know that when we add fractions, we like to find a common denominator. So we could look at the 3 and the 5 down below, and we could say, well, the common denominator is 15. Now that actually would work here. Or what you could do, a quicker way, as I said last week, was just to multiply both sides by 15, and then you're going to have some things canceling out. You remember that? You know how that works? You're going to have to put a big set of brackets around the left side, and a smaller set of parentheses or brackets around the right side. And why don't you get out your math notebooks, and let's just do this for a review. Let's see if we can knock this out in less than 5 minutes. Okay? Now that has a Y on it, but this is not Yomi's. This is going to be. Okay, I'm going to put a D for Dayo. That's not a grade of D now, by the way. That's not a grade, by the way.
Yeah, it's not good.
The D is for Dayo. Okay, now make sure you put today's date. I want the date on every time I come out here. So if we have to refer to a particular date, we can do that.
When's your birthday?
My birthday is January 5th.
Wow.
January 5th. You say yours is November 17th?
18th.
18th. What about you?
June the 1st.
June the 1st, okay. So anything special for your birthday?
I'm getting shoes.
Pardon me?
I'm getting shoes.
You're getting shoes? Ooh. Pretty good. Basketball shoes?
Yeah, $184.
$184. Whose shoes are they?
You're gonna be mine when I buy them?
I understand that. Is it Michael Jordan something?
Oh no, it's a Penny Hardaway.
What's his name?
Penny Hardaway.
Penny?
Yeah. Or he's a basketball player.
Really? NBA?
NBA.
What team?
Orlando Magic.
Well, I don't follow sports. I guess you've figured that out. But I played sports.
You played football.
I played football. But that was when I was young and didn't know any better. Oh, now, do I need to watch you every step of the way, as I often do? No. Why? Because you're smart? Okay. All right, well, I see you have done a great job of copying the problem. So I see you know how to copy the problem. I want to see if you know how to work the problem.
Okay.
Are you stuck already?
No, I'll put it in brackets.
Brackets are good. Brackets are a good thing.
3 times 5 equals 15.
Now, wait a minute. Let's see what you're going to do here. What's your strategy?
We'll have to find a common denominator.
You have to find a common denominator, and you've already decided what the common denominator is. Okay. 15. So, since we know that, what are we going to do with that piece of knowledge?
I'm going to bring it down for T.
Well, don't you want to write the 15 down there somewhere, so that your teacher can see what you did?
Okay.
You want to show all the steps.
Yeah.
Well, no, let me see what you did here. No. What I'm saying is, if you're going to multiply, you need the brackets indicate multiplication. Would you agree, both guys?
Mm-hmm.
So you don't want the brackets standing alone. You want something outside the brackets to show what you're going to do.
Yes.
Okay, and you know if you do it to one side, you have to
Do it to the other side.
say it louder.
Do it to the other side.
Do it to the other side. Okay.
Oh, you want another shirt on there? You want to pull off?
Because it's cold out. What do you think?
Then why don't you wear a jacket?
I wore a jacket also. I like to layer.
Layer.
Because when you go in, like if you go into a cold room, you can take your outer jacket off, but you still have your double shirts on. And when I go out tonight, the dance hall might be cold. How about that? I went out dancing last night.
Oh, you did?
Yep. Salsa.
Wow.
at the Clarendon Grill. You think I got any partners?
Yeah. You always do.
I always do. How do you know? Because I told you?
Yeah.
I might be making that all up. So I probably need to take film with me, Nancy, to show it to you.
Oh, we're supposed to be doing this.
No, let me tell you, first of all, I don't see the 15 out here. Where's the 15? Did you write it out there? Write it so I can see it. And right away, as soon as you indicated that, put it on the other side too, before you forget. Even before you start doing any calculations, set this thing up appropriately. If either guy is stuck, you could raise your hand or you could just turn around and say something to me. Well, you're a lefty. No, you're a lefty and you're a righty. We ought to have you switch places so that I can see what you're doing.
What?
I can't see through your hand. And I can't see through his hand.
Oh, I thought right-handed too.
You can write right-handed. Boy, you're really talented.
Yeah, I think that's what.
No, I don't want you writing right-handed if it's not comfortable for you.
I mean, I get it. We can't really do it.
I want the brain power going to the mathematics, not to the gymnastics. That's okay right now, but I might have you guys switch so I can see.
I'm stuck.
All right, switch sides. Switch sides real quick. Let's don't take all day to do this. Get all your papers. Now, what is that other thing there?
That's my history.
History. No, we need history right now. Okay, now swing around. I want you guys on the camera here. Kind of at an angle. Okay. Now, first of all, you're stuck. How could you be stuck on this? Since we spent so much time on it last week. That you knew this cold.
I do.
You do, but you're stuck.
What?
All right, let's see. All right, look. All right, right up here, you have your 15. And this means that the 15 outside of the parens means that you're going to multiply each term inside the parens by 15. Agreed? Okay. No. You set up this thing. First of all, you don't want an equal sign there. You wanted to have a plus sign, didn't you? Okay. You wanted a plus sign. But what you've done is you set this up like a standard fraction problem. Okay. You can do it like that. That's okay. But I'm trying to show you the quick way to do this. The quick way to do this would be, forget that. Okay. If I multiplied 15 by, your writing is so light I can hardly read. Is that X? So you got some extra terms in here somehow. What is this? Look. That is, read that first term to me.
That's X times 5.
X times 5?
Yeah.
Why X times? I see what you did. You're right. Okay, you multiply the top and the bottom of the fraction by the same number. And okay. And now, okay. So if you took it up to here, I shouldn't have scratched out what you did. You had 5x over 15 plus, what is that?
6x
over
15.
Okay. Now, it equals the stuff over here. Okay? Now, if you took it up to this term, how could you possibly be stuck?
Might as well do 15 down here.
Well, all right. If you insist on writing everything on the right side, we'll bring the that would be negative 33. Was that your intention?
Yep.
Okay. Over
15.
Over 15. All right. Now, okay, show me why you're stuck here. Why you don't know what to do.
Oh, I know what to do.
Well, you told me you were stuck.
I was wondering what are we going to do with these ones? 5x and 6x.
Well, what happens if we just had a 5 and a 6 and forget the x? If we had a 5 and a 6, then it would just be a third grade fraction, wouldn't it?
Yeah.
And what would you do?
We'll add.
You would add the what?
The 5 and 6.
5. Right. You'd add the 5 and the 6, and you'd get 13, right?
No, 11.
I knew that. Okay. You would get 11. Okay. Now, if you can add the 5 and the 6, why can't you add the 5x and the 6x? What is 5x and 6x?
11x.
13x, right?
11x.
11x. All right. Exactly. That's what it would be. So write that. Okay, you're determined to solve this equation the first way. I was trying to show you the quick way, but we'll do it.
The quick way.
This actually, there's not much difference in this equation, but there will be in later equations. Okay, so you want to write 11x over 15 equals what you have on this side, and then proceed to solve your equation.
11x over 15.
Well, write it. Now, show me where you're stuck. Okay, and let's see how you're approaching this problem. Okay, that's slide around a little bit more.
Yeah, I got a question. What happened? We added this, and we got 11x over 15. What do you do next? Or bring it?
Well, you bring your equal sign down,
Okay, yeah.
and you bring the right side of your equation down. Okay?
Yeah.
Over here. What did you do? What did you do here?
Multiply x over 3 divided by 3 over x. I cross it out and I got x.
Okay, what is your justification for multiplying this side by 3?
What do you mean justification?
Well, you have to follow some rules of algebra.
Yes.
And I think we only have 4 rules of algebra. Well, we have a few more, but the 4 that we're using mostly is you add the same thing to both sides, subtract the same thing from both sides, multiply both sides by the same thing, or divide both sides by the same thing. Now, have you used one of those rules here?
Yep.
Which rule did you use?
The one you divide by the same thing.
But that's not what the rule says. The rule says you can multiply the side by the same thing, not just a single term. Now look, do you understand what I'm saying?
Yes.
That's why we would put brackets around this whole thing, to indicate that we're multiplying the whole side. Now he remembered that. Okay, you forgot it. What's going on with that?
Smart man. It's sleepy.
You're sleepy. It's time to wake up because it's showtime right now.
Yes.
Okay?
Nice.
So let's rework this and multiply both sides by the same thing.
And that's like, no wonder.
Okay. You can multiply both sides by the same thing, or you can multiply the top and the bottom of this fraction by the same thing, the top and the bottom of that fraction by the same thing, in order to find the common denominator. That's what your brother's doing. You can do it either way.
With your help, is what he's doing.
Well, he didn't really need my help to get it that far.
Oh.
He told me he forgot how to add fractions, but he knew how to set the thing up. Okay?
I didn't forget how to add fractions. I was just wondering what we could do.
Well, that's part of adding fractions, what we do. Okay? If you forget what we do, you don't totally remember how to add fractions. All right. So now that I've given you these hints, can you take it from there?
Yep.
All right, let's do it. Because we're wasting a lot of time on this one problem. I'm hoping to do this in 5 minutes.
How many minutes has it been?
Oh, I don't know, but more than 5, I think.
It's been 8 minutes now.
Now, I could ask you to check this, but I'm not even going to do that, because that is correct.
Yep.
Okay? Anytime you get an answer and you think you're finished, what do you do with the answer?
Check it. Check.
Now, circle it first.
Oh.
Circle. If you have a page full of calculations, and you want to come back and look at your lab notebook later on, you may not know where that might be helpful to have the correct answer circled. Okay, I'm going to put a check there, because that is indeed correct. Well, he got it before you did, so let's hurry up here.
Yeah, before.
I can see we're going to have to do another warm-up before we...
Warm-up.
Well, this is warm-up, because this is what we did last week.
Yes, starting.
This is not new material.
Yep, it is.
Okay?
You said divide it by both sides? That's 3x, I divided it right here.
Okay, now, I don't think you should be dividing anything. Why would you be dividing?
I'm not dividing, multiply.
You're multiplying because of inverse operations.
Yeah.
So what are you going to do, your history while we're waiting?
Yeah. I think my version book.
All right. All right, I've given you the hint. Now let's see what you did with it. You can't really see what you did. Okay. I don't see what you did. Explain to me. You have a 3. All right. You're multiplying the left side by 3 over x. Why?
Inverse operations.
Inverse operations on that one term, sure. But if you multiply this first term by 3 over x, you'd have to multiply that term by 3 over x, wouldn't you?
All you did was do for this side and the...
I did, and you have not applied your multiplier to the entire side. The way to apply it to the entire side is to put parens around it, and then you'd have to apply this multiplier to both terms, and that would not be productive. It would certainly simplify this first term. You just end up with a 1, but it would complicate the second term. And it wouldn't. I don't think it would cause anything to drop out on this side. What you want to do, and you should have remembered this from last week, is you want to multiply. I recommend you multiply both sides by the common denominator, which is 15. Okay. Now let's see, and then you'd have to multiply this side by 15. Okay. Now let's see you do these calculations. In fact, let me watch you take the first step here. What happens when you multiply 15 by this first term, this x over 3?
You get 5?
You get 5. No, you do not. You do not get 5.
You do 15 times x over 3.
Yeah, exactly. 15 times x over 3. And what's the result of that calculation? How would you perform that calculation?
5x. This is 5x because I just cross this out and you get a 5, cross this out, you get a 1. Exactly.
All right, so that would be a 5x. And if you apply the same strategy to this side, you're going to get a different number. But if you knew what to do here, you know what to do here.
Yeah.
So let's hurry up and crank through these calculations, and let's see if you can produce the same answer your brother did.
Yeah, man, hurry up.
All right, well, we had to wait for you a lot of times, too, now, didn't we, in the past?
Yep.
Okay. But not today. All right. So today you're going to pile it on, is that right? Now, if you get stuck, no, I don't think you're getting stuck. You look like you know what to do here.
He doesn't.
Well, he might.
Yeah, you do over here. You do the same thing. For this.
Well, you know what to get there.
Now for this, you do the same thing. Right?
Well, the same type of thing. Well, I mean, what are you calling the same thing? What's your strategy for this side?
I'll divide it, multiply by 15.
Well, you did. I've indicated that right here by putting the 15.
Oh, okay. Oh, I see it.
All right. Are we getting it? Is he in the picture?
Yep. I'm in the picture? His head is in the picture. Thank you.
But his body's not in the picture?
His body, like, the front of his body.
Well, slide around a little more. Both guys slide around a little more. Okay. Okay.
Oh, I got this now. I got negative 11.
No, you can't get negative.
I mean, I got 11. I mean, 11. Positive 11.
Well, it's not negative 11, it's negative 3. So
It's
let's
negative 3, boy.
First of all, how many times does 11 go into 33?
Oh, my fault. Oh, sure. You took like 15 minutes already. Sure. You forgot the negative sign.
You better put the negative sign there.
You said it was, yes, it was negative. Yeah, I got it right. Next. Well, it took for like,
You got it right. Okay.
what, like an hour?
All right. Well, I can see that we need more than one warm-up problem, because that did take a while.
Mine didn't.
How about, is Yami in the picture?
Yep.
Okay.
Right there.
But no, I
No.
done it just No. I want those people in there.
No, you didn't. I fixed it.
All right, sit down. Yeah, let me see if he's still in the picture.
He's not in the picture at all. Like, he put it all on me.
But put it in the middle.
Yeah, it is in the middle.
Okay, come on around here. I'll bring a tripod next time.
Yeah, that's it.
All right, come on.
No, it's on me. No, it's not. I just checked it.
All right, but don't touch it. Fair enough?
All right, no, a little bit to the side.
Oh, come on.
All right. It's right. Got it.
No.
All right. It's not even. That's better.
Is that? No, you hit it again. You don't. Hey, Dayo, you don't touch this. Sit down. I'm trusting Yami more on this. Is that right in the middle?
He's gonna put it on me.
No, he's not. Is that in the middle? Is that in the middle?
Yep, it's in the middle.
Because I'm gonna go back and check, and if it's not, I'm gonna give you guys extra homework this week. Something to do this weekend. You think it's honestly now?
Yep.
All right, sit down. All right, next one. Let's take a look at 20. 20.
You took my. Oh man.
Okay. All right, let's write 20 down in your notebooks. 20 is y minus the quantity y over 2 minus the quantity y over 3 equals 2. Okay? Okay? Now, I can guess your strategy on this. You're going to do it the same way you did the last one, right?
Yep.
Well, that's all right. It worked.
Times 3. Yeah, I went to homecoming.
Pardon me?
I said I went to homecoming.
That's not nothing I really do.
You went to homecoming.
Mm-hmm.
Pretty good. So that means you had a homecoming football game?
Yep.
Who won?
We did.
Really?
We crushed them.
Who'd you
They
play?
lost.
We said, huh? We crushed them. 42-14.
Who?
Richard Montgomery.
You sure?
Yeah.
Was it Greenbelt Boys Club?
No, we were in high school. I'm in high school.
Okay.
Greenbelt Boys Club is for like middle school and elementary school.
All right.
Well, all I know, I'm going to high school next year.
You're going to high school next year.
Mm-hmm.
If you pass this year.
Yep. Which he might not.
And you, do I understand you're going to be playing football next year? If you put these down.
What happened?
I'm going to play for
I'm looking at the paper.
No, I want them down. I want you full on camera here. Okay. So, I'm sorry. You're playing football next year?
Yep.
You sure? You gonna make the team?
Yeah. You always make the team. Like they don't cut you. They don't cut people. They make you quit. Like they make you run and they want to quit.
I know the drill. Believe me.
Mm-hmm.
So just don't quit.
Yeah, they don't quit. But the thing that you have to work for is just to start.
Well, don't worry about starting. Let's just worry about getting out there.
Yes.
That's a lot of work, though, football. Particularly in August.
He has something in his leg.
Yeah, I think, you injured yourself?
But that doesn't really matter.
What? If
Yeah,
you break it, they can cut your leg off.
No, they're supposed to pin back in. They gave me the option to leave the pins inside there or take it out. I could leave the pins inside there for the rest of my life and nothing will happen.
Now, why do you have a pin in your leg?
So I broke it playing football.
Playing football? Playing what, boys club football? No, it's good. So it's just on one particular play somebody hit you too hard?
They flipped him. He flipped.
Yeah.
How could somebody hurt somebody as big as you?
No, I was playing running back and then I had the ball.
No, you
Like,
weren't
he
just
cut me.
running back.
How do you get yourself injured as a linebacker? I was running back and the guy cut my legs and I flipped and I landed on my ankles.
He flipped. You went backwards.
And was that last year or the year before?
It was 3 years. 2 years ago.
3 years ago.
No, the year before.
And you're just now starting to get better.
No, I've been better.
So could you have played this year?
Yeah, I could have played this year.
I recorded it, but I can't find the video. I can't find the camera.
All right, well, let's get back to the math problem. Now, how are both guys doing? How are both guys
I did
doing?
the same thing. I don't know what to do with this 2y.
Whoa. Now, first of all, let me suggest this. Let me suggest that you write down the problem in the future and then start your calculations on the next line. Okay? That might mean copying the problem over again.
Yep.
But I still think it'd be worth it. Show me what you did here, because I can't, this is a lot of scratching here, and I can't see what you did.
I want like the one on top. The one that
I have to look here at the original problem, because there's so much,
number 17.
no, it's not 17, it's number 20.
Yeah, number 20.
Okay. Oh, all right, y over 2. Oh, I see what you did. Okay. So you see that your common denominator is going to be, yes, I see what you did now. Oh, okay. Well, this looks correct so far. All right, so what is your problem? What are you asking me?
This is going to become 1 over 6, right?
All right, now look, why are you multiplying this by y?
Why?
What was your answer?
So we can make it 2y?
Well, why would you want to make it 2y? Look here. On the right side of your equation, you have a number. And we like to have numbers on the right side of the equation and letters on the left side. So why would you cook this thing up so that they're throwing a letter here on the left side? We just have to get rid of it later on. See, I don't think that's a productive strategy. Okay. What you've done here is correct, I think. Looks like it is. You would just forget that y. You would just set that equal to 2. You just bring down your equal sign here, 2. All right. So let's take the next step. And let's see what you did over here.
I got x equals 12. Is that the right answer?
It is, but you got that from your calculations, right?
Yep.
Let me see what strategy you used. Okay.
So I got the right answer?
It is right.
Well, good.
All right, but let me see what you did here. That's your original problem. So, so you just multiply both sides by 6.
Yes.
All right. Well, please put parentheses in here when you do that, so that I can see what you're doing.
All right.
Okay.
All right.
And once again, let's copy this down, and then let's start doing the calculations on the next line. So you'd have to write the problem over again.
All right.
But we still have a clean copy of the original equation.
Okay.
Okay? So you finished first this time, but he knows, apparently knows what he's doing, I think. As soon as Yomi grinds this one out, we'll begin what I want to start talking about today. So you obviously now have recalled the strategy that we're using. Okay. But you had forgotten it from last week.
No,
a little bit. You forgot a little bit. Am I right? Would that be fair to say?
Okay, yeah.
All right.
Done.
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 You didn't circle it. You're not ashamed of it, are you? Check mark. Okay. Check mark on both notebooks. Oh, I didn't put a check mark.
I finished before him. No. I finished before him because I didn't put check mark.
I'm the one that puts the check marks. Okay.
Thank you.
All right.
But I was just like a
Shut up and let's just do the work, okay?
Okay. Now listen. let me direct your attention to what I want to take in the next step. Because I think this is enough review of what we did last week, right?
Yep.
You got the strategy. Okay. Let's take a look at number 24. 24.
Number 24?
24. Now you write this down. You write this down while I read the problem for the camera. Okay. This is the quantity x minus 1 over 4 minus the quantity x minus 2 over 4 equals 1 plus x over 3.
Oh man.
Does that look more complicated?
That's way complicated.
Looks way complicated?
Yep.
Well, I'm going to show you why it's pretty simple.
Pretty simple.
Yes, it's pretty simple.
It's hard.
Wait.
No, well, not if I...
What question are we doing?
Oh, you don't have it written yet? This is number 24. 24.
X minus 1. Take it. 21?
Or 24. 24. Write 24 down real quick because we're waiting on you right now.
I wrote that.
You wrote what? Okay, you got it written? Now, this is more complex only because the top part of our fractions have an algebraic term rather than a pure number. Okay?
Yep.
But look here. Maybe we should work this through together. Okay? Because I'll write it down, and I'll show you what to do. So I'm writing x minus 1 over 4 minus x minus 2 over 4 equals 1 plus x over 3. Okay. 3 fourths is 12. Okay. If we have, how many fractions do we have in this equation altogether?
1.
Well, I see more than one.
I mean 3, sorry.
3. You see these 3 fractions. These fractions are a little, that's a pretty simple fraction, algebraic fraction, pretty simple on the right side. But we have 2 fractions on the left side, a little more complex. Okay? However, considering our fractions, we have a 4 down below, a 4 down below, and a 3 down below. We have denominators of 4, 4, and 3. So what would our common denominator be?
12.
12. Would you agree?
Mm-hmm.
All right. So, we simply apply the same strategy. I'm going to write this guy over, x minus 1 over 4 minus the quantity x minus 2 over 4 equals 1 plus x over 3. Okay. Now, what was the strategy that you used?
Divided it by the common denominator.
Divided it by, multiplied it by.
I'm multiplying.
All right, so look here. If I put a big set of parens around the whole left side of the equation, Yomi, are you paying attention here? I could put a 12 up here. Okay? Hey.
Hey, Mom.
All right. And I could put a 12 on this side. You see what I'm putting? You see what I'm doing here? Okay.
Yes.
Now, I want you to have a clean copy of the problem, and I want you to write the problem over. Remember, I asked you to do that? You forgot that. Okay. And same thing with you. Write down there. Just write it over.
All right.
But I want a clean copy of the problem on the first line. Okay, the problem's written. The strategy is going to be to multiply both sides by 12. So you know how to indicate that with parens. You have a 12 there, and you put a set of parens around your whole right side at 12. And do you have that written?
Yes.
All right. So let's take the first step. The first step would be what? This guy. Tell me what the first step would be.
4 equals 12 3 times.
Whoa, say this again.
4 equals 12.
The first step would be to multiply 12 by this first term. That's what you're doing. Okay? Now, if you do that, tell me what you just said.
4 goes into 12 3 times.
4 goes into 4 one time.
3 times.
4 goes into 4 one time.
4 goes into 12.
All right. But that gets rid of our 4 down below. Okay? So we have a 3 out here. Okay? And then we multiply 3 times what?
Times 12.
No, we don't multiply 3 times 12. That's 12. That's no longer a 12. That's a 3.
Oh, 3 times x.
3 times x minus 1. This is what we'd have. We'd have 3 times x minus 1. Now, do you remember how to do that multiplication?
Yes.
Right. Your multiplier would be applied to both terms here by the distributive law of multiplication.
Yep.
Okay, so 3 times x is?
3x.
All right. Minus? Not minus 1. 3 is applied?
4.
No, 3 is applied to a negative 1. So it would be a minus 3. Okay. And that's not a fraction anymore. Okay. Over here, let's see you take the first step. I don't even see your multiplier written.
Yeah, that's going to be...
Well, hurry up and write the multiplier on the
Sure.
outside. And on this side. All right, let's take the first step with this multiplier. This multiplier, 12, is multiplied by the first term.
Yes.
Okay. And what's the result of that multiplication?
That is... I don't know.
You don't know.
3. Get 3.
No. You have a 3 out there.
Oh,
Okay.
there's a 12 right here.
Yes, but 4 goes into 12 3 times. Okay, so for this moment, your multiplier is 3. And what is 3 times x minus 1?
3 times x, 2x.
Pardon me?
2x.
Oh, you're telling me that 3 times x minus 1 is 2x? How do you come up with that?
3 times x is 1.
X is not 1. We don't know the value of x yet.
Okay.
We haven't solved for x.
3x, no, it's 2x. Yeah, because 3x, that's 3x minus 1, so that equals 2x.
You can't subtract unlike terms. That's an algebraic term, and that's an arithmetic term. You can't combine unlike terms.
Oh yeah, I forgot.
You forgot. Well, that's an important thing to remember.
3x minus 1.
You've applied the 3 to your x. Don't you apply the 3 to this term also?
Okay.
If you have a million terms, if you have a million terms inside the parentheses, you apply that multiplier to each one of those million terms, no matter how many you have. So you applied it to this and you get a 3x. What happens when you apply it to this?
A 3.
A negative 3.
Negative.
Okay, all these are important details. So write that down there before you forget it.
So,
No, you're not changing anything up here. You're going down to the
I don't go down here yet.
Well, bump down to the next line. I want enough space here.
Come right sideways.
All right. Now, let's see you take the next step. Okay, we have a 3x there. What happens? What happens now?
Do the same thing.
You do the same thing. Let's see how you're going to do the same thing.
This
Right here?
3 once.
But it's no longer a 3. Do you know why? Because 4 goes into, oh, no, I'm sorry, it is a 3. We have 2 4s there. I'm sorry. I'm sorry. Okay, so you would have, this is what you would have. Let's take this off to the, let's take this up here. You would have 3 times, read it to me.
3 times x minus 1. I mean minus, 3x minus 2.
You have 3 times the quantity x minus 2. Okay, but you'd have a little bit more than that because you have to bring the negative sign in there. Okay? And of course your denominator has disappeared because you cancel that out.
Yep.
Okay? What is the result of this multiplication?
It's going to become 3x.
No, don't go too fast. First of all, let's take care of the sign first. What sign is it? What sign will it be?
Negative 3x.
Okay, it'll be a negative 3x. All right? So write that down there. Now what? All right. Now what's next?
Minus 5.
Well, first of all, let's take care of the sign. Take care of the sign first. What is the sign of this next calculation?
There's a subtraction sign.
You have a subtraction sign there, but you have a subtraction sign out there. What does that give you? Negative times a negative.
Equals a positive.
Are you saying that to make me happier because you really believe it?
I really believe it.
All right, then write the positive side there. All right. And then 2 times 3.
Yeah, 2 times 3 is 6.
Write it. All right. Bring down your equal sign. And bring down the right side of your equation. Oh, well there's something we can do over here. Okay, we can apply the 12 to both these terms. Do it the same way you just did that. Well, let's see what's going on with you. No, the 4 is canceled out.
Where?
4 goes into 4 one time, 4 goes into 12 3 times, 4 goes into 4 one time, 4 goes into 12 3 times. Your multiplier is 3.
Oh, yeah.
But the whole reason for doing this was to get rid of the 4s. Okay?
All right, let me rewrite that.
All you have to do is just erase the 4. Well, you've erased more than the 4. Okay? Now up here, that's 12. Okay? But you could have done this, you could have said 3 goes into 12 4 times, and then multiply 4 times your x. Do you see?
Yeah, 4x.
Do you see why it's a 4x?
Yeah.
Are you sure?
Yeah.
All right. And you don't need to write, you can erase the parentheses now.
Okay.
Okay? So then we need to be combining some like terms. How are you doing here?
I did it.
I don't think you're finished it. Oh, okay, fine. You're up to this point. But now we need to be combining like terms.
Yeah.
Do you know what I mean?
It's combining.
All right. Well, you have a 3x here, and where's your like term? That's not, no, that term.
Oh, like term 3x.
Like terms,
Like terms.
exactly.
Like them.
And these two are like terms. Okay? So let's take it, what is the result of 3x minus 3x?
0x. X.
0. 3x minus 3x is 0.
Yes.
Okay? $5 minus $5 is $0. All right? So we don't even need to write the 0. Then we need to combine these two guys.
3 becomes 3.
So we need to write that. Okay? Okay? And we need to see, well, there's nothing we can do. Oh, great, thank you very much. There's nothing we can do on this side, is there?
No. Yes.
No, there isn't. We can't,
No,
these are unlike terms.
Yep.
So put the equal sign down there and just bring that down. Okay, let's see how you're doing over here.
Almost.
All right, are you stuck on something?
Yeah.
What? Okay. Now, I don't understand what you have done here. Taking it up to here. Okay, well, I said you didn't have to write the fraction. Okay, up to here. No. You're just slapping these threes up here indiscriminately. What the rule says is you can, if you subtract 3 from this side of the equation, you have to subtract 3 from this side of the equation. If you subtract another 3 from this side of the equation, you have to subtract another 3. So you'd have to have a negative 3 and a negative 3 over there. Do you see? Okay. What I would do first, before you try to do any of this, is combine your like terms. If you combine the 3x and a negative 3x, what would you get?
You get